Okay. Explain the difference between the static class variable and a non-static class variable. When a static method belongs to the class itself and it is only used once, that is to say, when you only have one instance where you're going to use that method, that's where the static method belongs. While a non-static method is owned by each object that is generated from the class and is used where you will use multiple copies of that method. With a static method, you simply prefix the word static before the method. It belongs to the class, so there's no need to create an instance of that class. A non-static, on the other hand, a non-static variable or instance, on the other hand, would need to have an instance of the class created first in order to access that method. And I can show you another example, in fact. So right here, I have for the example, I have the hunt control method. Now this hunt control method within it, or class, has a method within it called the hunt method. And this hunt method is only being called once. It goes through its parameters and its code only one time when the hunt control is called. So every time we call the hunt control, which we can call multiple times, but the hunt within it, or the hunt class within it, is only going to be called one time. There's no need to call it any more times than that. Now, here is the hunt control exception, and this is different in that it extends the exception. It's a subclass of this superclass. I believe, I hope I'm using that right, but it basically is saying that we are going to be using it multiple times, and so we have to instantiate it first. So this is the instantiation of those different classes so that it can be used multiple times within the context that we need it. I'd just like to repeat the first part because I feel like I didn't get that quite right. So. So here we have the hunting scene. It's an enum class, but at the same time, it has to eventually be instantiated as an object itself, so that it can basically be reused over and over again. Demonstrate through examples from your program your understanding of when to use an array versus an array list versus an enum. So I'll start off with the first one, or with my favorite, which is enums. They're kind of my favorite because I feel like they're pretty straightforward. It's a collection of things where each thing or variable has one fixed value. Basically, what you put in is what you get out. So an example, I guess we're in an enum class right here, and I can just show you. Every single thing has one value. Squirrel, buffalo, deer, rabbit, bear, elk. They're each one thing. Now within that, they have different values that are plugged into them, but each one, in order to call it, you will call the squirrel, you will call the buffalo, you will call the deer. Another example of this that we have is in the river scene, or in the scene type, sorry. We have the is start, the end, the error. This is an enum class that when we need it, or when we need these scenes have their static value here. It's just is start, end, error, whatever it is that we have put here. Now, an array, however, it's a thing or a variable that can hold more than one value at a time. It accesses each value, or rather the value you want, by an index number, and you can hold either primitive values or objects created from classes. Also, an array has a fixed length, and once it's full, it's full. That's where an array list comes in. You can dynamically add and remove objects from the list, an array list at runtime, and these objects can be different data types but not primitive values. That's one of the big differences between an array and an array list, is the primitive values. So what this array is going to do, it's going to access it by by an index number. And when you choose that index number, it's going to basically go into its little file, pull out that whichever one it is, starting at, I believe it's 0. So 0 is number 1, 1 will be number 2, etc. And it'll go and pull that out and use the one that it needs to, but it can change. It can be that if it needs to symbolize a different one, it can go ahead and pull out number 2 and have that symbolize what it is. Okay, so here we are with an array list. Now this array list in particular is called supplies, and just as we said before, it needs to be instantiated. I hope I'm using that word correctly, but basically we need to create a new instance of this, which we do in the new array list supplies here. And the advantage to this array list is the fact that we don't know necessarily what's going to be in it when we begin. It's the supplies that the people are going to buy. But once they buy the supplies, we can go ahead and put it in the array list and set it in the array list. Demonstrate through examples of code that you've written for one of your individual assignments your understanding of how to use a basic for statement and an index to go through and access each element stored in an array or an array list. I'm guessing that's supposed to say and instead of or, but I'm glad that we kept this in because there weren't very many instances of when we used a for loop to go through an array list, an array, except for this one right here. And it's for j equals, the easiest way to do it is with a for loop to go through an array, by the way. And j is set to equal 0. J is less than items.size, which means basically the list of the length that we're looking for. Minus 1, and then j++, which basically means we are going to increment each time we go through the loop so that we can go through each item one at a time. How you go through it with a for loop, then obviously we set the temp to items.get, and we set them, and we ended up going or it ends up going through them all until it flags it as true or false. Well, I guess until it flags it as true, because when it equals false, it will continue to go through this loop. But anyways, let's move on to an array list. Okay, here we are with our array list again. And for this array list, we have a simple way to get it. Like I said, you have to use the index in order to get it. So with this array list of characters, we have the get wagon, which we call it wagon when we instantiate it. We have to get the characters. So you get it by the index get characters, and it plugs it into the array list. That's the only really good example I can find, except for case statements that we have in here. The case statements are also kind of an example of an array list, because it takes the case that you say by the indexed number, and it inserts it into the value. The next part is to demonstrate through examples of code that you have written for one of your individual assignments your understanding of how to throw, propagate, and catch custom runtime errors in your program. Well, the basics of any runtime error, this is going to be simple but complicated at the same time. It's a very kind of broad concept that I'm going to explain, but the basics of the runtime error is first we need to detect it. We detect it by setting up parameters in which something should fall, and then having a trigger go off when the value is set outside the parameters. Generally, this is done by triggering a -1, signifying that it is an error. There is a hierarchy to runtime errors, known as the try-catch statement, each inside of the other. And when you have one function, let's say function 5, it detects or triggers or throws an error, causing a -1. That -1 is returned or thrown back up the ladder's hierarchy to function 4, and so on and so forth, until it returns to whatever was triggered to also print out an error statement. So right here we have our very basic of the try-catch that we have, or that we've made for our Oregon Trail. Basically, it is to try and go through the program, and if it catches something such as a null value, which is what we set it to catch, then it will throw that null value back up, and basically I guess that's kind of why they call it a try-catch. It throws it back up and it catches it, and it says, okay, there was an error, this is what the error is. Explain when and why character stream class should be used versus a byte stream class to read and write data to a file. This seems kind of like an obvious question, but we use a character stream class over a byte stream class when we want to read or write to a file, because our programming languages generally are stored using Unicode conventions. When you want to process a text file, the file can be sent or can be processed character by character. In other words, it reads and writes in understandable language. It reads letter by letter, it writes letter by letter. A byte stream, however, reads and writes byte by byte and is more useful in processing raw data like binary files. I can only imagine if we were working on programming for an actual processor that this is probably what it would read and write, and would probably more likely be bytes because the processor just has switch states of 1 or 0. Anyways. Walk through an example of code that you have written for one of your individual assignments and demonstrate your understanding of how to write character data to an external file. Well, as we have right here, we already have the different classes and methods set up here that we can go ahead and call to within our code. But basically, we wrote to get it to have a new input stream reader. It's Oregon Trail.file equals new buffer reader, new input stream reader, system in. Which means we're trying to import a file to read it, and then when we want to print out a file, it's Oregon Trail.out file equals new printer writer system.out true. And the reason why it needs to be true is because if it's false, it would be triggering that whole try-catch statement and throwing up an error instead. But the string file path that we have is log.txt, so it's actually creating the log, or the file that it's going to create is going to be literally called just log.txt. Okay, so we're supposed to go ahead and show you what we have for our working game. We don't have like everything as far as I know, but let's go ahead and just run through it. So please enter your name. We are Bob. We are going to start a new game. Bob. Bobby. Bobby. Bobbette. Bobberton. Okay, we are going to leave in, I guess, April. We are going to be a banker from Boston. Do you want me to read this to you? I guess you can read it. You'll need warm clothing in the mountains. I recommend taking at least 2 sets of clothes per person. Each set is $10. How many sets would you like to buy? I guess 10. Because that's what we recommended, right? 2 per person, 5 people, 10. Ammunition. Let's buy 5. Wagon wheels. It's a good idea to have a few spare parts for your wagon. How many would you like to buy? Let's do 2. Wagon axle. It's a good idea to have a few spare parts for your wagon. How many would you like to buy? Let's do 2. Wagon tongue. Blah, blah, blah. It's a good idea to have a few spare parts for your wagon. How many would you like to buy? 2. Total funds remaining 170. Total funds spent 1,430. I guess we're done. Okay, so Oregon Trail location. Get location. Oops. Date, health, pace, ration. Continue on trail. This should take you back to the game. You see, that's where I believe we were done. About as far as we got with the game. Didn't get all the way through it, but we basically got to the point where we started on the trail and we kind of got a little confused on how to set up the map and get the person to travel. The hardest part, I think, was getting the person to travel from one place to another. Check supplies worked the last time I checked it. It should have anyways, because I was supposed to yield and just print out a little list of everything that you had in your supplies, but I didn't do it this time. I'm actually very surprised by that. But that's the end of the game. Thank you for your time, Professor, and you have a great day.